This is our IoT testbed system. It allows various devices to interact with each other while logging the communication going through. Now, let's use it to run a simple test as an example to walk through its functions. In this test, a temperature sensor, a motor, and a control system will be connected to our testbed. The control system is programmed to monitor the temperature value sent from the sensor and send commands to the motor based on the temperature. Now, we click the Start New Test button to start a new test. First of all, we need to set the configuration of the test. Based on the client's requirement, the users should be allowed to set the test name, test duration, and whether the test should stop or not when any disconnection happens during the test. The three buttons on the right side allow you to reset the configuration to default value, import a configuration you saved in the past, and export your current configuration to local. Now, we move to Start Test. In the Device in System table, you can see all the devices being connected. Now, the temperature sensor, motor, and the control system are waiting for the start of the test. Database is also online and ready to record the communication data during the test. Any exceptions happen during the test will be printed in this table. Now we can start the test. In the console, you can monitor the status of each device. Remaining test time is given here. The sensor is sending temperature value to the control system, while the control system is now sending stop to the motor. When the temperature rises to above 22 degrees centigrade, it will send slow command to the motor, and the motor will start to rotate slowly. When the temperature rises up to 26 degrees centigrade, it will send fast, and the motor will rotate faster. When time's up, the test will stop automatically, but now we stop it manually by clicking Stop Test. The messages transmitted during the test we did just now have been logged in a table. The major events such as test start and stop, device disconnection and reconnection are logged in another table associated with the data table. Besides the content of each message, the name of the device that sent the message and the time when it was sent can also be found in the table. Except for physical devices, our testbed also allows the users to create virtual devices and connect them seamlessly to the testbed. Now we will create and run two virtual devices on another computer, and you can see them in the testbed console. This function allows the users to simulate the behavior of any device they need, especially when this kind of devices is not available. Our testbed is also modifiable enough to allow any communicating devices to connect to it for testing. Check this out. This is the robot developed by the robot team. Their team spent around an hour to make it connected to the testbed. This allows us to create an application to control it and log the commands we send to the robot.